In this video, we see overall what are the motion planning methods suitable for autonomous driving vehicles. So we all know that autonomous vehicles are the future one, and which can enhance road safety, efficient traffic flow, and decreases fuel consumptions. So one of the vital essentials for realizing autonomous navigation is to have an efficient planning algorithms, and also there should be algorithms to understand the situations around those autonomous vehicles, and based on that it has to make a good decision making. So the vital thing is to make a path planning such a way that it is safe and collision free, and to reach its destination considering the vehicle dynamics and the presence of obstacles around it. So there are hierarchical way of planning algorithms called route planning, path planning, maneuver choice, and trajectory plannings. Here I have to mention that though this paper is not well written, the reason that we chose this paper is to understand the overall mechanisms around the autonomous navigations related to the planning algorithms. So this paper says that they are not mainly focused upon the route planning; they are mainly focused upon the path planning, and maneuver planning is something related to like a behavior planning, and the trajectory planning. So the section two, they give some kind of terms, definitions of the term. What is configuration vector, what is configuration space, what is the state of the vehicle. For example, the state of the vehicle can be its position and its orientations in three different directions, and the main vehicle dynamics or vehicle model they consider for this different algorithms is the bicycle model. And what is mean by constraint, like holonomic constraint and non-holonomic constraints. Though the definitions are not clearly explained, possibly this paper would help you for you to understand what are the terminologies involved in autonomous navigations, and like for example what are the actions are taken by the autonomous vehicle for the safe maneuvering, like steering and linear and angular accelerations. So these are some of the terminologies that one has to understand to know about what are the algorithms involved in the autonomous navigations. It's a very basic thing. What does mean by path? Path mean by like kind of for example, what they says about the path is a continuous sequence of configurations. The configuration is a state vector beginning and ending with some certain conditions. And what is meant by path planning is therefore finding those geometric path from the initial configuration to a given terminal configurations. So these are the some kind of a basic terminologies being defined in this paper. And what does mean by maneuver? What does mean by maneuver planning? Maneuver planning is nothing but the behavior planning, like what is the best decisions you can take based on the situations surrounding the autonomous navigations. And finally, trajectory planning, the local path planning, is represented as a sequence of state visited by vehicles, and it can be a parameterized and non-parameterized, and it can be parameterized both in time and space, or parameterized in the action space like velocity and the steering angle. So these are some of the terminologies improvised in this paper. And how does that search space can be defined? There are a different way the environment can be defined, like a physical space that can be embedded, like can be in a Voronoi diagram, or it can be embedded in a occupancy grid, and it can be embedded in some kind of like kind of a driving corridors or stack lattices. So these are the terminologies where we are forced to refer to some other paper for a deeper understanding about these terminologies. As myself found my hard to understand what are the terminologies through these papers. So I deeply recommend to go through this paper only to understand the different terminologies involved in autonomous navigation, but to have a complete understanding and to complete thorough, deeper feeling of those terminologies, I kindly refer to some other papers which I may try to refer you in future videos. So what are the planning things? So this paper says that there are two way of planning things. One is incremental approach and the local one. So the incremental approach is something again they are saying about the previously mentioned. like it starts with route planning, then they go for a manual planning, like finding based on the situation awareness what kind of uh, state it embedded, like a finder state machines, like what state it would be embedded, that autonomous navigation would be embedded. Based on that state, path planning will be done, and based on the path planning and the maneuver planning, the final trajectory planning can be computed, which has been tracked by the actuators. So this incremental search can be a broadly, like they have mentioned, two types. One is RRT. The RRT is utilized by an MIT team in the Urban Challenge. And these are the algorithms for the RRT, which we will try to deeply explain what is the concept behind RRT in maybe in the future videos. The other one is called as lattice planning, where the space is discretized into lattices, and from there planners try to compute the best possible path. So again, I'm going through roughly because the details are not that clear enough. Only the terminologies I'm going through. The local search is something like, again, it can be a what that there can be partly into other, again, the two categories. It's like a lateral offset method. The offset can be again classified into two categories: lateral offset in action space and lateral shift in the state space. So lateral shift in the action space can be some like a DWB planner, MPPI planner. Lateral offset can be planner which make like kind of a trajectory, different trajectories, smooth trajectories. From that, a best trajectory would be taken based on how far it is near to the principal path and free from the dangerous obstacles. Partial motion planning is something like kind of a limited time space where we use RRT to compute the best path. So these are the action space, lateral offset, and state space action method. This is something like resembling like kind of DWB planning. For more reference, you can go for ROS to NAV2 architecture. This is the lateral offset method where they fixed some horizon, time horizon, or space horizon. From that, try to solve some optimization problem to generate candidate of trajectories. From that candidate of trajectories, if this is a principal path, it tries to maintain the principal path as far as possible, but at the same time, it gives more weightage to the collision-free path. So this is the time constrained RRTA method, and maybe lateral they may be employing smoothing techniques to as RRT is producing a discontinuous path. And motion planning, as earlier it's I told about that it can be like a behavior planning, and based on the situation and understanding that they can improvise various decision making planning, like Markov decision process, to make effective decisions, like what kind of state it has to be for that particular configurations. The last one is like a local path planning, like a trajectory planning. That can be a two broad categories. One is like a generating a smooth geometrical curve using polynomial spirals, clothoids, or Bezier curves. So this can be a piecewise smooth, and also can be solved through a two-point boundary value problem at each time moment. The other method would be like kind of a directly trying to compute the best actions using the MPC, model predictive control methods. So these are the overall ideas being given in this paper. And this is the diagrammatic representation. I told that path planning will be like two methods: incremental and local. Incremental can be RRT and lattice planners, and local can be like a rollout trajectories based in the action space or the state space. And it's a partial motion planning, like a time constrained RRT. And manual planning is like kind of a decision making, like understanding the situations around it. And trajectory can be an optimization curve, geometric smooth optimization curve, or directly the model predictive optimal control method. And these are some of the constraints that please go through this paper. I'm not going deep into this. And finally, they give some condensed version of what this paper is about. And sorry, I have to go a bit above to show you the condensed version of this paper they have mentioned in here. So I'm just reading as it is. Planning for autonomy can be divided into three main levels: search for the path, search for the maneuver, and search for the best trajectory. Searching for the best path can be further divided into searching for the best series of path towards global, and searching within a limited local time and space horizon. As far as maneuver planning is concerned, obstacles and risk assessments are employed, while decision theoretic approaches such as market decision have been recently emerged to account for interactions with the traffic environment. Lastly, in trajectory planning, the chosen geometric path is bounded with kinetic and motion model constraints and further optimized to assure a smooth and feasibly journey along it. Optimization is based either on the choice of geometric curve to represent the path or a model predictive control. The classification tree summarizes the approaches, like I said in the figure 10, summarizes these things. So those are the things being given in this small paragraph, which is a summary of the whole paper. And these constraints that it's not that been important to the crux of this paper. And these are some of the constraints that will be considered for the future considerations. And conclusion, as mentioned, it summarizes what are the different things that we have come across in different sections of this paper. Hopefully we'll see in some other deep explanations related to the motion planning in some other videos. Thank you.